So today we're going to talk about terminating and repeating decimals. We've already talked a little bit this year about converting between fractions and decimals, but now we're going to take it a step further and include negatives. This will be Chapter 5, Lesson 4, if you need to look it up. Okay, so let's talk about these two words before we talk about the negative part. So we've got terminating and we've got repeating. Let's talk about the terminating first. Terminating will always have an end. Now, it might have a lot of numbers, but it will always have an end to it. You will also be able to add zeros to the end without changing the value. These are the numbers that you're probably familiar with. When you started learning decimals, you learned the terminating decimals. Now, how do you remember that? If you're really good with your language root words, think about things like term. Okay, we might use that for a marking period. We call it a term because it's a period of time that has an end to it. You might have a terminal, like a bus terminal or a train terminal or a phone terminal if you're into data and coding and things like that. The company Terminex will come and put an end to all of your bug problems. And the movie The Terminator was supposed to put an end to all the bad guys. All of these things have an end or are an end, and they're related to the word terminating, which means to end. All right, let's talk about repeating. And it really does what it sounds like. The numbers repeat. They'll also go on forever without end. Now, this is what happens when you use the same digits over and over and over. Sometimes terminating decimals will have just one or two, maybe even three numbers that repeat, but there's still a clear end. Repeating decimals will go on forever, and there are symbols that we use to show that. Sometimes you'll use the three dots, called an ellipse. Ellipsis. Three dots shows that it goes on forever. But there's also something called the bar notation, which is this little line that you draw over top of the number or numbers that you want to repeat. So you don't have to list out 300 of the same number. You can write like one or two and put this little symbol over top of it. Okay, so let's see what this looks like. Here are some terminating decimals. 3 4/10, 82 hundredths, 2 577 thousandths. Now you can see here, this does have a repeat, but it will not go on forever. There's no indication that this goes any further than this second 7. All right? I'm going to recycle these digits, and I want you to be clear that these are terminating and the ones over here are repeating. So let's look at this. If this number were to repeat, it would look something like this, 3 with a whole bunch of 4s. Now, I chose to use the dots for this, but I could also say 3.4 and put the bar over just the 4, because that's the only number that repeats. And this would be read as 3.4 repeating. The place values don't really apply because of the repeating part. All right, let's look at this next part. 82828282. Again, I've given the dot saying that pattern would continue, the 8s and the 2s repeating indefinitely. What if I wanted to use bar notation? I have to put it over the stuff that repeats, so both numbers would get the bar. And we'd say that as 82 repeating. For my last one, it looks like the 7 would continue. Now remember, this side was a terminator. It absolutely had an end. But if you had a number that continued to repeat like this is possible. You've got some numbers that do not repeat and other numbers that do repeat. So that would look like 2.57, and the bar would only go over the 7. The 5 did not repeat, but the 7 did. So the 7 got the bar. Okay, now I also got to say it again. This side and this side are not related. These are terminating decimals. These are repeating decimals. All right. All right. So in a calculator, we have come such a long way scientifically. We can send people to outer space. We can have people orbit the Earth. We can come up with vaccines in under a year. Crazy, crazy scientific discoveries. I still have not found a calculator that has the bar notation on it. Now, this calculator only costs maybe $15. I've had calculators that are $150 and $200. Some fancy, fancy scientific ones. They still don't do the bar notation. It's crazy. So what do you do if you're using a calculator like this, or you're using a calculator on your phone and you need to show a repeating decimal? Well, I'm going to tell you to just fill the screen. So for example, if I wanted to put in this 3.4 repeating, I would do 3 point, and then I would just fill the screen with fours. Don't go crazy. You don't have to count them all. Usually by the time you filled the screen, the calculator is going to get your point. All right. Now, it's not going to give me back anything like this. It's going to show me all those repeaters again. The one thing that I need to caution you about, the calculator, because it can't show bar notation, will round the last number. It will round the last number. So let me set this up. Let's say that I have, I'm not going to be able to do that 8 part with the way that I'm showing this, but I'll show you right now. So there's that example, right? It kind of feels like that 5 is going to go on forever. Well, what if it did? What would be the next digit? A 5, right? Well, don't we take 5 up to the next number when we round? That's exactly what the calculator did. So you, as an educated mathematician, have to recognize this and say, oh, that's really a repeating 5. The calculator just can't show it to me. Isn't it great when you know more than a calculator? Okay, let's talk about how to get some of these. How do you change a fraction to a decimal? We've talked about this year. You simply divide. Whether you do it on pencil paper with the traditional division sign, or whether you grab a calculator and do it that way, you're still going to do the numerator divided by the denominator in that order. All right? So let's try one of these. What if we had 5/12? Well, in the olden days, we would have set up a division sign, and you can still do this. There's nothing wrong with it. Sometimes it's all you got, and you have to do it pencil paper. So the top number is going to go inside. I'll tell you about that decimal and zero in a second. And the bottom number is going to go outside. As it stands, 5 can't be divided by 12. But I know that I can add a decimal and a zero. Take that decimal up top, and now it's like 50 divided by 12. Ignore all the decimals. We already got that taken care of. 50 divided by 12 is going to be 4. 48, 2 left over. I'll bring down the 0. 20 divided by 12 is 1. Bring down the 8. Still got to do is here. 8 divided by 12. 7 is going to be too much. So let's go for 6. Oh, I got another 8. Well, that's going to give me another 6 here. 72, subtract, again. When you do it this way, you start to see real quickly that this is going to repeat because there's no option to change it, right? Every time we did this, I got a 6, I multiplied 72, subtract. Every time I kept getting a remainder of 8, and then it turned into 80. If I kept going, I'm just going to get all 6s across the top here. All right, so you make the decision and say, well, this is really 0.416 with the bar over just the 6. And I don't have to do more than 2 or 3 to figure out. It's just going to keep going. Oops, I didn't want you to see that yet. Now, if you had a calculator, and I'm totally okay with calculators for this part, because I want you to understand the concepts and not get stuck in the division. Some of these can be brutal. We just divide. 5 divide 12 equals, and that's what I get. There's an example where it rounded it, but I know that this is a repeater, so I'm just going to make it be 0.416 with the bar. All right, what if we had -2/9? Oh, there's a negative? Yes, there can be negative fractions, there can be negative decimals. We're starting to talk about rational numbers. So we start you off integers, which are just the regular counting numbers. Now we're going to kind of blend all of your knowledge together. Nothing changes. We're still going to treat this 2/9 the same way that we treated every other fraction, divide it, and then we'll just put a negative sign on it. So since I have my calculator, 2 divide 9 equals, and we get 2 repeating. So 0.2, and then I'll put the bar over it. The negative sign will go out front. That's it. That's all there is to it. Mixed numbers, nothing different. The whole number is going to stay the whole number part, and the fraction will just get changed the way that it has. So this 2 and the negative sign can stay. I'll grab my calculator. 2 divided by 3 equals. Looks like a whole bunch of sixes. Sorry, you're getting that glare there. So we'll put this as 2.6 repeating with a negative sign in front. And then one more, a positive mixed number, 1.5 divided by 8 equals, I got 0.625. That 1 came down, even though it doesn't say it here. Remember, I didn't put the 1 in the calculator, so we'll just bring that down. Negative signs do not affect the process. You still divide, you still do the repeating decimals, all of that is the same. One last thing I want to point out to you. Where does the negative sign go? If you've got a fraction, there are 3 spots, and it means the same thing in all 3 spots. Your negative sign can go in the numerator, your negative sign can go in the denominator, or your negative sign can go even with the fraction bar. All 3 of these represent negative 1/2. In a decimal, it's going to go in front of the leftmost number. So for most cases, that's going to be the whole number. Maybe it's ones place, maybe it's a hundreds place, whatever. It's going to go in front of whatever number comes with it, whether it's a terminating decimal or whether it's a repeating decimal. The negative sign always goes out front. Okay, there's lots of little details involved with this, but most of this you've already seen before. We've already talked about how to divide. We've already talked a little bit about negatives. So really, there's just a couple new pieces that you have to blend together.